This one we're looking at the first ever Queensland Math Methods Tech Active Multiple Choice exam. So you've got 10 questions to solve here. You've got full access to a graphics calculator. I'm using the Casio over here. And you're going to see that you're going to want to use your calculator constantly on every single one of these questions. It's multiple choice. You don't have to show any working. You just have to get the correct answer and your calculator is going to let you do it. Let's get on with the first question. Question 1, I didn't expect to see many limits questions, but we have one here. The limit of this equation as h approaches 0. With a calculator in your hand, this is very easy. All you need to do is put in a very small value for h. So just type in the equation here. H value, I'm just going to put 0.1, 2, 3, 4, 5, that many zeros, minus 1. And I need to make sure that I'm very careful about having the same number of zeros. 1, 2, 3, 4, 5, 1. Count them up, make sure you're doing that right, otherwise you're going to get a strange answer. And you can see we get an answer of 2.4849. Now you can add more zeros there and you're going to get closer and closer to 2.5, but the answer is going to be 2.5. Now you can do it another way in graphing mode. So if you just get out of here and go into graph mode, you can graph this just by typing the equation in, changing h's for x's. You're using this key for the x, otherwise you're going to run into trouble. Minus 1 over x. And then it'll draw that. Okay, now if I just move this around with my arrow keys a little bit, you can see here that it's passing through at 2.5. Now I can zoom in and make sure that I'm telling the truth with that. I'll zoom in right just by arrowing there and looking very close there. And you can see that when x is 0, it looks like it's passing through 2.5. It actually isn't. There's a gap, a discontinuity in our equation, but that is what it approaches. So 2 different ways to use your calculator to come up with the answer, but the answer is 2.5. Look at question 2. Now you can read through that whole question here. All of this context doesn't matter. What we have is an equation, pH equals negative log base 10 h plus. If a solution has a pH equal to 0.2, find h. So this boils down to an equation that looks like 0.2 equals negative log base 10, and our h plus is just x. And we can use our calculator to n solve this, or solve n, whatever they decide to use here. So option is the thing I press, calc, and then solve n. And then we just type in our equation here. So 0.2 equals negative log. Now you don't need to write 10, log means log base 10, and then just our x. Close the brackets, and it's going to solve that for us. Now it'll say more solutions exist, which always worries me, may exist, and we get an answer of 0.63, which is there, so that's B. Now again, you can graph this an alternative method. What it boils down to is an equation like this, y equals negative log base 10x. So if I type that in here, y equals negative log, again there's a base 10 there, you just don't need to write it, and we do that and we draw it, we get a graph that looks a little bit like that. And we can find out what x is when y is equal to 0.2 by using gsolve and doing what's called an xcalc. Now an xcalc, you sub in your y value of 0.2 and it gives you your x value, which is 0.63. So 2 ways to solve it. This is one where you want to be a bit careful here because your calculator will give you the answer, but it'll give you 2 answers and you're going to have to pick which one you want. Let R be the region enclosed by the graph this, the x-axis, and the line x equals negative 1 and x equals 1. First step, graph that function there. So we want x and then e to the x. All right, let's graph it, see what it looks like. Whoa, okay, my view window must be like really funky at this point. So let's change our view window here. we want between -1 and 1. So I'm going to go outside those bounds to -2 and 2. All right, let's have another look at that, see how it looks. All right, that's a better view. I would like to zoom it down in the y-axis just so I have a really good understanding of what this actually looks like. Let's go -4 to maybe 5. Okay, that's great. Now, what I want is the area between -1 and 1, the area enclosed. So I'm going to use gsolve, and I'm going to use this little integration button here, and I'm going to do mixed. Now, let's look at what mixed does. Okay, so I can select my lower limit. I'm going to go from -1, and then it says select upper limit. Now, just type +1, or just 1, and it gives me, it shades it in, right? Now look at these numbers. It gives me an answer of 0.7357 and another answer of 1.26424. Both of those answers appear as option A and option B. So my calculator is leading me astray here. I've really got to think. I'm being asked to find the area enclosed. So that's this number here, right? This little trapezium here stands for the area, the actual area. This bit here is the integral, because remember, if you find the integral between a positive value and a negative value, this under the curve is going to be negative and this is going to be positive, and they're going to cancel each other out. Whereas this bit here is treating this as a positive value and this as a positive value and adding them together. So that's what we want. 1.26, and I did that by using the mixed integral section of my Casio. The question here is a real doozy here because they give you a function, but it's got like a p and a q value, and it says where p is greater than 1 and q is between 0 and 1. So you might be thinking, wait, I don't have exact value, so I can't like use my calculator here. But you can just try something and see what it looks like. Let's say, well, p is greater than 1. So let's let p equal a number greater than 1. Let's say 3. And q is between 0 and 1. So let's let q be like 0.5. All right, so let's type in this equation exactly as it appears there. So we'll need to be a bit careful here. This is log p. And I want to use P3, right? So I click option here and I just click the calc and I can do log AB here. And then that lets me put in a weird base instead of 10. So that's going to be 3. This bit's going to be X, and then the plus sign, and then the Q is going to be 0.5. All right, let's look at what that looks like. All right, looks something like that. We can see that it's passing through between 0 and 1. Now, let's look here. This one looks like it's passing through between 0 and 1. This one is like passing through between 1 and 2. This one is passing through on the negative side, so that's probably not right. And this one is passing through 0. Okay, so it feels like this one might be our answer here. Why don't we zoom right out? So zoom out, and we'll just do like a big zoom out. Maybe that's a bit too big. Zoom back in a little bit. When we do that, we can see that it looks like the asymptote is staying between 0 and -1, right? This one, again, is the only one that does that. So I've used my calculator here. You should have been able to do this just by thinking about transformations, but I'm trying to use my calculator to help myself out as much as I can. You can just look at this and say, well, I know what the equation of log base 10x looks like. So I know that if I shift it by q, I'd be shifting it to the left, right? But I'm using my calculator. I've used some concrete examples. I've got something there. I'm feeling very confident my answer is C. Question 5, and it's the first one. You've really got to put pen to paper here and think a little bit. We're given a velocity function and we're asked to find the displacement function. So we're going to have to integrate that. Looks something like this. There's some brackets in there. Now, it's going to be easier if you bring the 40 out the side here. That we can just integrate this and integrate that. E to the negative t, you divide by that negative 1, which is just going to give us negative e to the negative t. And integrating negative e to the negative 2t, you divide by that negative 2, which is going to end up giving us positive 1/2 e to the negative 2t. And don't forget, there's going to be this plus c here. Now, we're told in the question itself, object is at the origin initially. That means that its displacement is 0 when time equals 0. So we get these sorts of equations. We put 0, the initial displacement is equal to, and then our initial times here. All right, so what does that give us? That gives us 40 negative e to the 0. So e to the 0 is 1, so that's negative 1, plus half, and we get e to the 0 again. E to the 0 is 1, so plus 1/2 plus c. All right, so that gives us 40 times negative 1/2, which is negative 20 plus c is 0. That means that c is equal to 20. And so finally what we get is this equation that I've written up here, but not plus c, plus 20. Remember, this is multiple choice, so I'm not going to waste my time having perfect, neat working out. All right, so now that I've got that equation there, I'm going to graph it over here. Be really careful when you've drawn your equation that it's the same as the equation you've written here. I've actually made a mistake in mine because I need a negative e, but the rest of it looks like it's going to work just fine. So let's draw it. Uh-oh, syntax error. When you've made a syntax error, don't panic. Just look through the working and find the thing. I've made a mistake here with using the wrong x. I've used the x from the letters instead of the x from the variables. Easy mistake to make when you're using a computer like I am at the moment. And then you draw it. All right, and you'll get something that looks like that. After that, it's time to look at our options and see which of our options looks like that. And you can see the only one is C. Now you can change your view window to make it look more like that, but that looks like that's what our solution is. To question 6, I think, which is going to be a little bit easier. Oil is leaking from a tanker at a rate of this. All right, so we've been given a rate function. So that might give you a hint that you might be looking at integrals, areas under curves, things like that, if you've got a rate. Okay. Determine how much oil leaks from the tanker between t equals 0 and t equals 10. All right, so it is a rate question where we're finding the area under the curve to find how much liquid has leaked out. So really straightforward question because we're just going to graph it on our calculator. Make sure that you've typed it in correctly. Press the draw button. Now, if you can't see it, don't panic. Just click, let's click zoom and just click auto. That often just fixes your problem. And then, okay, that looks pretty good. I need to zoom out here. And the reason I know I need to zoom out is because I really want to go between time 0 and time 10. And then I can move this here. Okay, beautiful. All right, and then I'm just integrating between those. So G-solve, more options, integrate between, just going to use this one here. Type in the values I need, lower limit of 0, upper limit of 10. And let's hope one of our answers is there, 38,910. The answer is A, done. Question 7, which is very clearly some sort of probability question. 10% of shoes are defective, 2 defective shoes from a batch of 20. This is a binomial probability question, so we get to go into our stats mode here. Now, it says the probability of getting 2 defective shoes. That means exactly 2. So when we go into our distributions, we're looking at binomial and we're looking at BPD because we want the exact. All right, so I'm in lists here. We shouldn't be in lists. We need to be in variables, so set that up. Now, our number of trials is 20. the probability of success, in this case being defective is considered success, 0.1, and I want 2 successes. That's what our x value stands for. Now I can click execute there, and I get a probability of 0.2852, which is this one right here. I almost forgot, but I have to show you another way of doing it as well, and that's in the run mode. So you just go to option here, stats, distributions. We want a binomial distribution and a BPD. And then you just need to make sure that you get the syntax right here. So you go the number of successes, the number of trials, and the probability, so P, which was 0.1 in this case. And we get 0.2851. I don't love this one because I can never remember the syntax to do it. That's why I use stat mode usually. The very few questions where again you're going to have to put pen to paper. Determine the size of angle A. So we're trying to find this one here. Now we know 3 of the side lengths, but we don't know any of the angles. So we can't use sine rule. We're going to have to use cosine rule here. So recall the cosine rule. Looks a little bit like this. Now the unknown angle I want here is actually the letter A, and so that's what we're going to put there. So the unknown angle is this capital A. Now the side that is opposite A is the thing that we're going to put here, which is 8.8 squared. And then it doesn't matter where we put the other 2 sides, what order we put the in. So it's going to be 11.3 squared plus 9.9 squared minus 2 times 11.3 times 9.9. Okay, now you'll notice that my letters aren't corresponding with my formula letters. It really doesn't matter. What matters is that this side corresponds with this angle. This side corresponds with this angle. It doesn't matter what order you put those ones in. Okay, so your cosine rule, it can be used in a variety of different ways. All right, you really need to rearrange that now to make A the subject. So what we do is do 8.8 squared minus this, and then divided by all of that. A formula that looks like that. This should be familiar to you. And now we don't want to know cos A, we want to know just A. So we can move the cos from here and do an inverse cos on this side. Some students have memorized this formula and they don't have to do this rearrangement here. If you've memorized this formula, you can just do it straight up. Now you just need to type that into your calculator, and it's a good idea to be able to type it in just as you see it there. In its entirety here, and you'll see cosine negative 1, 8.8 squared minus 11.3 squared, negative 2 times that. And if I click execute, I'm going to get the wrong answer. So let's execute this and get the wrong answer, get it over and done with. All right, and I get an answer of 0.8464, which is nothing like any of those answers. And the reason for that is because I am in radians mode when I should be in degrees mode. Just go to Shift, Setup, go down to where it says that one and click degrees, and then click execute again, and we'll get a different answer, 48.49, which is this. You really need to be very comfortable switching from degrees to radians, radians to degrees, because different questions across the paper will require you be in degrees mode or radians mode. Question 9. Now question 9 is an absolute nightmare if you don't fully use your calculator. Your calculator is your best friend here. What we have is a displacement function, and we're being asked what's the acceleration at this particular time. So if you didn't use your calculator, you would have to find the derivative of this. And to find the derivative of that, you're doing some kind of product rule. And then once you've got the derivative of that, you'll have to do the derivative of that. And that's probably going to have another product rule in it. It's an absolute disaster. Whereas if you use your calculator, you can click Option, Calculate, the second derivative, and then you can type in this derivative exactly as it appears in the question itself, just using x's instead of t's, because we've established that they're the same thing. I'll just make sure that I put this in the right spot. I need my bracket in the right spot, otherwise it's going to go... Alright, so just checking. Second derivative, x ln x minus x, and then cursor outside, and we want it at a particular time, at time 3. So what this says is find the second derivative of this function at x equals 3, and we get an answer, 0.333. A student might spend 7, 8, 9, 10 minutes on this question if they've got to derive and derive again and then sub the time 3 into it, instead of spending how much time it deserves, which is about 60 seconds or so. Your calculator. Question here, the approximate value of x, where the graph of the function. This changes concavity. All right, so you think concavity, you should think second derivative. It changes concavity when the second derivative is 0. So I need to find the second derivative first. All right, so that's a simple matter of just finding the derivative of that. First derivative is relatively straightforward, 3x squared, 12x, 7, and then that negative 2x becomes positive 2 sine x, and then I need to find the derivative of that. It's relatively straightforward. Derivative of 3x squared is 6x, 12x is just 12, and then 7, that's 0, so that goes away, and then the derivative of 2 sine x is 2 cos x. And now we can type that into our graphing mode on our calculator here. Got it there. Let's draw it. Let's sketch it. And so we get a sketch that looks something like this, and we were looking for roots, and you can see we've got one there. Now we can just sort of zoom and try to get a sense of what this thing looks like. Just put like an auto zoom on it. You can see it looks pretty cool. And now I'm just going to g-solve that and find a root. And I get negative 1.89, which is one of our answers. All right, that's question 10. 10 of the multiple choice tech active questions done. I really hope, having gone through those, you see how heavily I'm relying on my graphics calculator there, and how important it is that you're fluent in using your graphics calculator and comfortable with typing in equations, doing g-solves, solve-ends, all those sorts of good things. Because if you don't, you're going to end up trying to do everything algebraically and you're going to run out of time, because there's another 10 tougher questions on the way. All right, I'll see you in the next part.